In this video, we are going to discuss paper 5, question 2 evaluation paper. It is 970-252 variant May June 2024 that we are going to solve. So, what we have in question, a student investigates the resonant frequency of a metal rod. The metal rod of length L is suspended from the two rubber loops. They are showing these are the rubber loops, and this is the rod that they are showing us. A sensitive micrometer with a cone is positioned at the one end of the rod. The microphone is attached at an oscilloscope. Okay, the rod is hit gently with a hammer. The periodicity of the trace produced on the oscillation is determined, and the experiment is repeated for a different lengths of L. It is suggested that T and L are related by this equation. So this is our main equation of question 2. Okay. Where C and N are the constant, a graph is plotted of LGT log of T on the y-axis and log of L on the x-axis. Determine the expression for the gradient and the y-intercept. Okay. So when you have to determine the expression, whatever is going to be on the y-axis, you have to make that thing the subject. So we have to make this thing the subject. Okay, what equation we have? We have T is equals to 2ln divided by C. When I apply a log on both sides, so it will be log of T. T is already a subject. Okay, so log of T is 2. um, how we can write this thing? We can write this thing as log of 2 by C plus n log of L. We are using log property. Okay, so the when you use the log property, you can write down these 2 by C and L power n are multiplied with each other, so they can be written as like this, and this n is on the power, so this can come before the log. Okay, so these are the log properties. So if you see, you have to relate this equation with this equation. Y is equals to mx plus c. What is this equation? This is straight line equation. Okay, you have to do this thing in all the questions. So if you relate these things, if you see this y is represented by gt, and this um, first let's rearrange this equation. I can rearrange this equation as lgt is equals to, I can write this n log thing first, log of L plus and log of 2 by C. Then now I can relate this thing. This is basically the y, this thing is the x, and it is plotted on the x-axis if you see in the question. And this thing is representing C, and there you have n. Okay, so gradient is equals to this thing. If you remember this equation, y is equals to mx plus c. In equation, this is gradient, right? So gradient is m is equals to n, and c is equals to log of 2 by c. So I can write as this is the, and this c by definition from the equation, if you, this is called the y-intercept. Okay, this is from the definition of straight line equation. So y-intercept is equals to lg 2 by c. Okay, let's move forward. Part B, value of L and T are given in the table 2.1. You have to calculate the and record values of log of Cm and log of T in table 2.1. Include the absolute uncertainty for log of T. Okay, so let's move to find this values. First, I'm going to fill this thing. So this is log of 54. Okay, so to find this thing, what I have to do, take the calculator, put this thing is basically log of 54. This is for your reference, you will get answer. Okay, we will write at 1.73. Okay, we will round off. What is the main thing for the student? How much decimal places you have to write? So you have to see there are two significant figures, so there should be two decimal places. Okay, so because you're taking this value, this from this equation, so significant figure of this will determine the decimal place of this value, so you will only write two decimal places. Okay, so log of 54 is 1.73. Okay, here we will do log of 70. If you see there are two SF, it's mean there should be, here we have two decimal places. Okay, when you solve it on the calculator you will get 1.85. I have rounded it off to the two decimal places. Same, log of 86 will give you 1.93. And now you see there are three SF. So when you calculate log of 108, you will get, we will round it off to three decimal places, 1 2 3. Okay, moving forward, in the next there are again three SF, so there should be a three decimal places, 2146. And log of 167, again three SF, there should be a three decimal places, 223. Right? Okay, you can even write down one more decimal place. Okay, but you can't write one less decimal place, that will be wrong. One more is acceptable, but one less is not acceptable by the examiner. Okay, but make sure um, you move in a sequence. What I have choose the same number of significant figures here and the same decimal places here. Okay, that is how I am solving this thing. Okay, so moving forward, we have to solve this thing, log of t, where we have this column that we have to look into. Okay, log of, and this was derived from this column. Okay, so log of t, log of 24, you have to find first. So what I will do on the calculator, I will do it log of 24. This log of 24, and again we have to apply same rule. There are two SF, so whatever the answer will come, you have to round it off to the two decimal places. So I'm getting 1.38 for this thing. Okay, log of 24. Same as log of 32, I am getting 1 point, sorry, 1.51, then 1.59, 1.69, 1.81, 1.87. Same rule is used. 2 SF, two decimal places. Okay, so now we have to write down their uncertainties. So how we can write down the uncertainty here in the first place? Okay, the rule is, for the log values, what you can do, the uncertainty will be, I'm going to write it down at the top. So uncertainty is basically delta log of t will be equals to excuse me, log of t maximum value minus log of t actual value. Okay, so what we are talking about, we are talking about 24. I'm going to solve this thing in detail, so you should know. So 24 is plus minus 1, so it can be, maximum value can be 24 plus 1, that is 25, right? So that is 25. So and actual value is, this is the actual value. So what I can do, log of 25 minus log of 24, whatever the answer is, that will be the uncertainty. And for the uncertainty, you have to look at the uncertainty of this thing. This have one SF, right? So your answer should also have one SF. Okay, in the uncertainty. So what we are getting for this thing, it is 0.02. Okay, moving forward, for 32, what I will do, I will do log of maximum value, that is 33, minus log of 32. That will give me 0.01. For the next thing, I have to see this thing. The maximum value is log of 40 minus log of 39. This will give me plus minus 0.01. Again, now this value, now the maximum is, it is plus 2. So log of 49 plus 2 is 51 minus log of 49. So 51 minus 49, it will give me 0.02. Then here it will be log of, again, 66 minus log of 64, I will get 0.01. And here for this thing it will be log of 76 minus log of 74. So it will be plus minus 0.01. Okay, so we are done with the table. I hope you understand this thing. Okay, so moving forward, in C part, what you have to do, plot a graph of log of t and log of L, and you have to include the error bars for the log. Okay, so let's move forward. We have the graph. Let me copy the values from it. So we have to use this table in the graph where, okay, okay, I'm going to paste this thing there so I don't have to move again and again up and down. Okay, so let's paste it on the left hand side. Okay, so let's do it like this. Okay, so what we have log of t on the y-axis, and log of, this is y, and log of L, this is x-axis. This is x, this is y. Okay, so the first point is 1.73 and 1.38. Okay, if you see each division, this is 1.7 and this is 1.8. So each number one box, this is showing 0.1 division. Okay, so I can, 1.73 will be at this point. This is 1.73, and you have to plot it on the y-axis. It is 1.38. So where will be 1.38? Okay, if I see these divisions, this is 10 divisions are equals to 0.05. Okay, how I know it's 0.0, 1.40 minus 1.35, it's 0.05. Okay, so when you, so d will be equals to 0.05 divided by 10, so that will give you 0.005. Okay, so this is one division what it is showing. So I have to look for this thing. So this will be somehow third, and okay, this will be 1.38. Okay, let's do it like this. Then moving forward, the next point is 1.85 and 1.51. 1.85 and 1.51. So 1.85 will be at the middle, okay, and 51 will be at this point. So this is 1.51, and this will be a point. Okay, 1.85. Okay, you have to do it carefully because all the calculation rely on this thing. Moving forward, next point is 1.93 and 1.59. So 1.93. 9 is here, so 1.93 and 1.59. 1.59 will be here. 1.59. Okay, so making the coordinates, but I will. Okay, so it will be. Okay, I will get this point. Moving forward, on it's difficult to plot digitally. It's much easier on the piece of paper when you're doing it because you can see the whole diagram. Now the next point is 1.69 on the y-axis. So 1.69 on the y-axis is this, and on the x-axis it is 2.03. So 2.03 will be 2.03. Um, okay, 2, 1, 2. This is 2.03, right? So it should be 2.03123. It should be somewhere at this point. Okay, let me look at it. 2 point. Okay, it's making sense. Now the next point is 1.81. So 1.81 will be at this point, and 2.14. Where is 2.14? 2.14 will be 1, 2, 3, 4. This is 2.14. So moving, it should be somewhere at this point. 2.14 is here. Okay. And the next point is 2.23. 2.23 is 1, 2. This is 2.23, and on y-axis it is 1.87. 1.87 is, this is 86, this is 87, and it is 1.87. So 2.23 is, it should be in this block. 2 point, it was 2.23. Okay, so from here 1, 2, 3, and okay, so this is what we have. So what we have to do, we have to draw a best fit line here. Okay, so this is what we have. You have to take a scale, and for the best fit line, what you have to do, you have to make sure that you will cross through maximum points, and number of lines, number of coordinates below and above the line should be almost same. Okay, so what I am getting is, okay, this seems good to me. Okay, let's see this. Yes, it's making sense. Okay, somehow. Or I can switch this thing slightly. I can do this thing like, okay. It should be slightly downwards, so it can be balanced here, but I think it's good to go. Okay, let's move forward. So this is the best fit line. You have to label this thing, this line with, this is best fit line. Okay, now you have to draw, what we have to draw? We have to draw the error bars. So now look at the points. Let me use a different pen. For, and the error bars are on the y-axis, right? So it is for 1.38, it is 0.02. Okay, and we know this two boxes are showing 1. Okay, because one box is 0.05, so 2 multiplied by 0.005 will give you 0.01. So two boxes are equals to 1. So first error is, you have to look at this thing. This is basically 0.02. So from here you will move 1, 2, 3, 4 boxes above, and 1, 2, 3, 4 boxes below, and you have to draw these lines as well, okay, to show the boundary of this thing. Then for next is 1.5, it's 0.1, so two boxes, 1, 2 above, 1, 2 below. Okay, then moving forward for 1.59, it is 0.0, so it is like this, like this. And for 1.69 it is 0.02, so four boxes at top, four boxes bottom. For 1.81 it is two boxes up, two boxes down. And then for 1.87 it's again two boxes up, two boxes down. So this error bar, this line should pass through the this error bar as well. Okay, so it's quite difficult to plot the line on digitally, but you can make this slightly downward, okay, when you're plotting on the paper. Going forward, now what you have to do, if we see the question, draw the straight best fit line and the worst acceptable line. Okay, what you have to do for the worst acceptable line, there are two ways. One way is you can draw the line from the top of this error bar till the bottom of this one. Okay, so this is like this. You have to take a scale and you can join these. Okay, one way is this. Or you can choose the bottom of this and top of this error bar. So you can plot it like this as well. So it's your choice, whatever you choose. So I'm going to choose from the top of this one and the bottom of that one. Okay. So this will, okay, it will be like this. So I'm going to plot this thing here. Mm, it should be slightly above. Okay, let me adjust it as much as I can. Okay, so, okay, so let's plot this thing. You have to plot this thing, you have to make a dotted line, okay, for the worst fit line. The best fit and the worst fit, you have to label them to distinguish. What I have done, I have do a dotted line, and this will be the worst accepted line. It should pass through all the error bars, okay? So that is another thing that you need to keep in mind. Now what we have to do, we are done with this thing. We have to label it, we have labeled it. We have to determine the gradient of the best fit line, and you have to include the uncertainty. So the gradient of what you have to do, you have basically, let me explain you what we are going to do next. First, you have to find gradient of best fit by rise over run. Okay. Then what we will do, we will find gradient of worst acceptable line. They haven't asked us, but we need this thing. Why? Because we have to find absolute uncertainty. Then for the absolute uncertainty, you will find the difference of them. You will find the difference of gradient of best fit minus gradient of worst accepted line. Okay, that will give you the absolute uncertainty. Okay, so let's move forward. Let's do it. You have to choose any 2 points on the coordinates, and the 2 points should be, but you have to keep in mind the 2 points should be more than half length apart, okay, of this graph, and they should not be the data points, they should be the different points. Okay, so what I'm going to choose for this, I'm choosing one point as my, this is this is clearly cutting this thing. Okay, or I can choose, I can choose this point. Okay, you have to show it on the graph as well, so let's do it like this. And second point, okay, second is I'm choosing, I'm choosing this point. Okay, so it's, okay, perfect. So I can erase this thing. This is the run, and this is the rise for this thing. Okay, so I have noted the values. Let's do the calculation for this thing. And when I do the calculation, I will get, I have rise is 1.88 minus 1.565 that I have chosen, divided by the run was the 2.2 minus 1.9. That will give me 1.05. Okay, and for the worst accepted line gradient, I can choose 2 points. What I am choosing here, you have to show it on the graph. So let me choose a different color. So I'm choosing this point, one. Okay, let's draw a line. Okay, and second point I'm choosing is this one. Okay, this point is the second point that I have chosen. So okay, what you have to do, try to draw a dotted line for the worst acceptable gradient. Okay, so I can erase these things, and this should also be a dotted line. So I'm making it. Okay, so we have the coordinates for the worst acceptable line as well. Let's do the calculation. When I do the calculation for the worst acceptable line, coordinates are On the y-axis, 1.67 minus 1.425 divided by 2.01 minus 1.76, I get 0.98. And when I minus them, it's 1.05 minus 0.98. That will give me 0.07. Okay, so the gradient is simply this value and the uncertainty is this value. So I can write as 1.05 plus minus 0.07. Okay, let's move forward. In the next part, fourth part, what you have to do, determine the y-intercept of the line of best fit, include the absolute uncertainty. Okay, so now you have to find the y-intercept. So to find the y-intercept, what we have to use the equation y is equals to mx plus c. Okay, and c is equals to y minus mx. The student got confused sometimes. They think this point where this line is cutting the y-axis is the y-intercept here. You can't take it directly. You take this point as a y-intercept directly when this x-axis is showing 0 at this point. So when you take the equation mx plus c is equals to y, this will be the 0, so y will be equals to c directly. So you will take the reading on the y-axis, but this is not the case here. Okay, on the x-axis we don't have the value 0, we have a different value that we have to put and we have to solve it for that thing. Okay, so let's do the calculation. We have to use this equation, and from there we know c is equal to this thing. I'm going to find this y-intercept of best fit line. I'm writing this bf, and I will find y of worst fit line as well. Why I'm finding worst y-intercept of worst fit? To find the uncertainty by the same method. Okay, and by calculating these both, the uncertainty will be equals to the difference of both the values. Okay, the c of best fit minus c of worst fit. Okay, that we have to do. So gradient we already know. We have calculated the value of m above, and we have to take the points when the best fit line is cutting at this point. So for the best fit line, the y is 1.35 here. Y is 1.35 and x is 1.7, and gradient we have where we have gradient we have here. Okay, so let's put the values. I will get 1 point. I'm using this equation. Okay, y is equals to 1.35 minus 1.05 into 1.7. You will get minus 0.435. Doing same thing for the worst fit line, gradient is same. No, gradient we have to choose for the worst acceptable line gradient. Okay, so worst acceptable line gradient is where it is. It is okay. So the y point is 1.37. It is cutting at this point, and the gradient was of worst acceptable line is 0.98, and x is 1.7. I will get minus 0.296. Okay, to find the difference, what I can do, just ignore the negative sign. You have to find the difference of both the values. So it will be 0.296. This will give you 0.139. So this you have the y-intercept, and this you have its uncertainty. So it can be written as minus 0.435 plus minus 0.139. Okay. Moving forward in the D part, they're asking you, using your answer in A and C3 and C4, determine the value of N and C. Include the absolute uncertainty in your values. You need not to be concerned with the units. So N we know from above that N is equals to gradient. Okay. So simply whatever the value was of the gradient, how we know N is equals to gradient? There we know. Okay, in the first part. and the value of gradient is here. You just have to write down this thing. So it will be equals to 1.05 plus minus 0.07. Okay, now you have to tell the c. We know c is equals to y-intercept. So you have to find c. C was, let me move up. Why we have, yes, c is there. So c is in log of 2 over c. Okay, so this c is, so y-intercept is equals to log of y-intercept is equals to log of 2 by c. What I can do, I can take the anti-log on both sides, so it will give me 10 power y-intercept, and right side the log will be cancelled with anti-log. It will be 2 by c. So for the c of, you have to rearrange it. C will be equals to 2 by anti-log y power y-intercept. Okay. So C will have two values. One C will be for best fit. That will be 2 divided by 10, the y-intercept of best fit. Okay, the you and the y-intercept of best fit was 0.435. Solving this, you will get 5.44 into 10 raised to power 5. So you will get 5.44. Okay, now you have to find the uncertainty. For uncertainty, you have to find C of worst acceptable line as well. So this will be 2 over 10 power, the worst acceptable y-intercept, that was 0.296. That will give me 3.95 into 10 raised to power 5. Okay, and delta C will be difference of both of them. So I can 5.4 10 raised to power 5 minus 3.95 10 raised to power 5. The answer I get will be 1.49 10 raised to power 5. So it will be plus minus 1.49, and you can write as 10 power 5. Okay. In the last part, the experiment is repeated. Determine the length L of the rod. Give a value of t of 0.1 millisecond. So from the main equation, we know t is equals to 2l power n over c. You have to find L. So L power n is equals to ct over 2. So L is equals to root of ct over 2. Solving this thing, you just have to put the values. So L is equals to n, I have 1.05. Okay, root of 0.05. C is 0.10 10 raised to power minus 3 time they have, um, this is the time that I have written, that is given here millisecond, and C is 5.44 10 raised to power 5 divided by 2. Doing the calculation, you will get 1.05 27.2. I will get 26.75. So we are done with the question 2 of this paper.